let's look at this one now. So here I have to do something. It's the formula for cos P plus cos Q given in the list of formulae. I would not like to open this one now, but because it is cos A plus cos B, actually the formula is given in the formula list. So, and also it is MF10, not MF19. So I believe there's something a bit different in this one. Now I'm going to write down the formula. It's just the fact of making use of this formula actually. Using the formula of cos P plus cos Q. So the formula for cos P plus minus cos Q, I'm just going to write it down here, equals to now because there's a plus, the difference between plus and minus is because I have a plus here, then it's going to be 2 cos half P plus Q cos half P minus Q. I'm not going to move on with trying to prove this or whatever. I'm just going to show you the formula here. So this is the formula if I want to use it with these two. Let me see what I have. So UN equals to 4 sine n minus half sine half by 2 cos half 2n minus 1 plus 1 cos half 2n minus 1 minus 1. So I have here four sine n minus half sine half. Now this one at the top can be used for something else. Let me show you. Actually, if this is for plus, then if I have a minus here, then then we actually have to make this sort of change. Instead of plus, if you have a minus, we have to put a minus here. Cos becomes sine. This cos becomes sine. Nothing else. So I realized that this is actually something like this. I can rewrite this thing as n minus half, right? So half plus n, no. It has to do something with 2n there, to be honest. So I'm going to leave it out for now. Actually, I don't have any space for doing that, to be honest. Okay, I'm going to leave it out for here like this now. Then I'm going to write out at the bottom 2 cos. This is going to become n, and this is going to become minus 1 plus 1, 2n. So it's become 2 cos n cos n minus 1. Now I need to do something at the top to get rid of the sign here, which means I want to bring this into a single number. Okay, I'm going to try making use of this formula here, which is if I rewrite this one, I'm going to get here cos n minus 1 minus cos n. I need to somehow bring it into such a form that I can rewrite this thing as 2 sine n minus half sine half, right? So if it is cos n, then I can put this inside here, then I'm going to get here n minus 1 plus n minus 1 minus n. So I'm going to get here 2n minus 1 and just minus 1. Minus 1 means that I'm going to get here sine minus 1, which means it's the same as sine 1. So sine minus 1 is the same as minus sine 1. So it means that I can try writing it down like this, sine half, right? So this is the same as, because I have here half here in the formula, I can write it down as half into 1. And here, if I want to bring a half, I write down half into uh, half into something which equals to n minus 1, right? N minus half. So I have here 2n and I have here 1. So, and because I have a minus 1 here, this 1 actually gets removed. This minus actually gets removed to become plus. All right. Then I can multiply that plus with this one right here. Then this eventually becomes cos n minus 1 minus cos n. Then this is exactly the same as this by this minus this by this. If I do that, then I can cancel these two out. I can cancel these two out. So I get here 1 by cos n, actually 1 by cos n minus 1 by cos n minus 1. So what I've done here is that I noticed that if I rely on both of these formulae, then if I look at the formula booklet, then how can I even bring it up? If you notice that the bottom one is pretty easy because I have a plus here. For the bottom one, I can directly imply this formula. But for the top one, I noticed that because it is a product of signs, I can make use of this formula to go back into this form so that I can use it with the denominator here. If I have a both numerator and denominator with the same causes like this one and this one, I mean only these two, where we have a product, where we have a difference at the top and product at the bottom, I can make use of that and make out this formula in this notation here. What I've done is that I notice I have 4 sine this one. So first of all, I replace this with this. I can cancel these 2 with this 4, so I can get here 2. Then I notice that because I have a half, if I want to put a half here, just to make sure I can half 2n minus 1. I can write half 2n minus 1 carefully, 2n minus 1 in it. So 2n minus 1, I can write it down as n minus 1 plus n, and I can write this one as n minus 1 minus n. But wait, n minus 1 minus n is minus 1, right? So how do I get a 1? This is how. I know that sine of minus 1 equals to minus of sine 1. I can bring the minus frontwards like this at the front here, then I can write it down like this. Then this means that this minus multiplies with this minus so that the minus is cancelled out. And once I have this notation, I can go back to using this form right here. Now, here's another confusion. Now, in this case, I have here P plus Q, right? I need to consider n minus 1 and n, either one of them as Q. They considered here n to be Q because I have here n plus 1 plus n, and then we have n minus 1 plus n and n minus 1 minus n. So n becomes a Q and n plus n minus 1 becomes a P. But eventually, overall, we still get a minus here. So as a result, we won't have to worry about our answer here. We just want to make use of both of these just to write down a statement here and get into this conclusion, which is typically what they ask us to show, which is why this, I mean, even dealing with the slightest mistake is not an issue, but we have to make sure that we correctly use these two actually. Then we can get into this form. Anyways, it was an interesting question, so I had to explain it quite some. And also it took me time to understand it. So next up, we have using a method of differences to find this one. Easy. Um, it means that I need to write down 1 by cos 1 minus 1 by cos 1 minus 1 plus 1 by cos 2 minus 1 by cos 2 minus 1 plus 1 by cos 3 minus 1 by cos 3 minus 1 plus dot dot dot. The trick is to actually write down as much as I can. 1 by cos n minus 1. So I'm going to, no, n minus 2 minus 1 by cos n minus 3 plus 1 by cos n minus 2 minus 1, 1 minus, this is 1. Then we have a n minus 2 plus 1 by cos n minus 1 by cos n minus 1. I mean, you probably don't need to write down so much, but I typically like to write it down like this. Cos 1, cos 2 minus 1, exactly same thing. Cos 2, cos 3 minus 1, same thing. Cos 3, cos 4 minus 1, same thing, and so on like that. Cos n minus 1, no, cos n minus 2, this cos n minus 2, exactly same thing. I mean, this is the same thing as that. This is the same thing as that. This one will eventually exist somewhere inside. I do have a cos n minus 3, n minus 4, and so on. So it means that I only have left 1 by cos n. Now, here's another issue. No, it's okay, it's okay. Minus 1. No, yeah, minus 1. The reason is that this becomes cos 0. We know cos 0 is 1. So we have a minus 1 by 1. So we write it down as 1 by cos n minus 1. Explain why the infinite series this does not converge. Okay, this is un, right? Now, if we put any infinity here, let's just say I put here infinity. Okay, it's really difficult to do with infinity case for cos because we do not know exactly what this could be for infinity. But if we notice yeah, so I can go back to here. Un equals to 1 by cos n minus 1 by cos n minus 1. If n equals to 1, 1 by cos 1 minus 1 equals to 1 by, no, no, actually, it's not the case, sorry. There's actually something else. N may be any value such that cos n equal to 0 or cos n minus 1 equal to 0. So 1 by cos n or 1 by cos n minus 1 or both could be divergent in that case. That's the way, I mean, that's the answer I think around in my mind. Let's see what the mark scheme says about it. question 2. Okay, now let me show you the mark scheme what it says. I mean, I say the latter, but this is also a valid point. Cos n oscillates as n goes to infinity, so it does not converge. Or states oscillates or refers to divergent values of cos n. As I said, n may be any value such that cos n equals to 0 or cos n minus 1 equal to 0. So this or both could be divergent in that case. So if this becomes 0, then this means that there are certain divergent values. So yeah, that's it. I mean, this part required a bit of a thought, I mean, especially for me to explain it. But once you get that into your mind, it doesn't take more than 2 minutes to solve this one, even though this is a lengthy 2-minute question. Everything else is pretty simple. Except for this one, if you happen to refer to divergent, it's fine. Otherwise, the typical one would be oscillation.